Hello, everybody. Thank you so much for being flexible last class period. We're kind of doing back to front because what you did during class was basically like homework. And this is going to be more me talking instead of you listening to somebody else talk. So this is more about confidence intervals, which you got introduced to. Make sure that you are taking notes. And let's get started. So you already learned what a confidence interval is. Confidence intervals, we know confidence as a word already. It means that we can be pretty sure about something, even if we aren't 100% sure. And it tells us what percent confidence the mean will be within a certain range. So I've highlighted kind of in the example here, what parts relate to that definition. So we can have 95% confidence that a mean is between 341 and 359. So it just gives us some idea of where the mean might be, even if we can't find the actual mean because we aren't taking every single person out of the population and averaging them together. We're taking samples and using that to estimate. So let's look at some more details to this. How can we actually find a confidence interval? So this is our equation, and you've actually seen part of this. If you notice this second half of the equation, you already copied down as your standard error. So to calculate a confidence interval, we're going to use this formula for the margin of error. The z, that's the z-score. So whatever z-score we want, maybe we want to find a confidence interval for 2 standard deviations away from the mean. Well, 2 standard deviations away, that's a z-score of 2. Or we want to find a confidence interval for 1 standard deviation away. That's a z-score of 1. So remember, the z-score tells us how many standard deviations away from the mean we are on a normal curve. And then this second half is going to be something that we go into more detail on the next slide. So make sure that you're copying down this equation. So these are the 3 parts that go into this equation. We have the z-score, which I already talked about. And then we have n, which is the number of people or individuals in the sample. So we are always going to be dividing by whatever the sample size is. And then we have the sample proportion. So for example, from that video you did last time, if 52% of the people agreed with candidate A, they were going to vote for that guy, then the sample proportion would be 0.52. 52% becomes 0.52. So always a decimal, right? And so we're going to multiply the proportion times 1 minus the proportion. So let's look at an actual example and work this out. Suppose a poll sampled 1,000 people from the US and 520 people, 52%, think the president is doing a good job, compared to 48% who don't think so. Find the confidence interval for a 95% level of confidence. And I gave you 95% level of confidence, that's a z-score of 1.96. We do have tables for these, but I've just given you that. So we know what our z-score is. Well, we also need to know our n, our sample size, and that is the 1,000 people. So I'm just going to highlight 1,000, that's an important number for us. The z-score, that's an important number for us. And then the other important number for us is the 520, the 52%. And if we want to find our proportion for that one, well, we can take 520 divided by 1,000, and that's going to give us 0.52. So that 0.52, that's our P that we're going to plug into this equation. So I've plugged it in like this. You can see I took the same equation and plugged in the numbers that I got from the question. And so when I actually simplify that and solve, I get 0.0310. So now this number here is my margin of error. It's not my final answer though, because remember that what a margin of error tells us is the distance away from that proportion that's part of our confidence interval, right? So prepare for a really terrible drawing. She's gonna do it. All right, so we have our normal curve. Pretend this is a normal curve. I know it's awful. And basically what we have right now is some estimate. That's my 0.52, right? And the 0.301, that's our margin of error telling us if we go plus 0.031 or minus 0.031, that is going to be our confidence interval. So we're just moving plus and minus away from the proportion. And that's going to give us the interval that we think will include the mean. That's really what we're saying here. So the way that I solve that, I'm taking my proportion 0.52 here, and I'm going to add 0.031. That's how I got my 0.551. And then I subtract as well. So that's what this plus or minus means, is I'm going to do two things. I subtract to get the 0.489. I add to get the 0.551. And that's my confidence interval from 48.9 to 55.1%. So according to this data, you can conclude with 95% confidence that, you can conclude with 95% confidence that, come on, 48.9 to 55.1% of all Americans approve of the president. Ah, that's how I got the thing to go with. Okay, so take a moment to copy this down. The last thing that I want to go over for you is conditions for valid confidence intervals. There are always a few rules that we have to follow to know that what we're doing is actually going to work, especially having to do with the way that we sample things. So you guys should be used by now to looking for random samples. We want to make sure that we are randomly sampling out of the population, not picking only a few people who are all the same that don't represent the population. We also want the normal condition. So the normal condition, it has to do with that normal curve, but it actually means that we want greater than or equal to 10. We want at least 10 successes and failures in each sample, which means successes and failures would just mean, like, if we have some people who say yes to a question and some who say no, we want at least 10 who say yes, at least 10 who say no. We want at least 10 who are voting for one presidential candidate, at least 10 who are voting for another. If you take a sample and you have like 95 people in the sample who were successes and then five people who were failures, you probably have an issue because it's not probably representative of the population. The other thing we're looking for is the independence condition. So we want to make sure that we don't have anything that's going to mess up the statistics in another way. And what that is we don't want to take most of our population as a sample. We actually want N, so that's the sample size, to be less than 10% of the population. The sample size should be less than 10% of the population. So for example, in this one over here, I took 5 people as my sample. I see 2 problems with that, right? 5 people in my sample, there's no way I'm going to have 10 successes and failures in that sample. It's too small. But my sample size is less than 50. So my second problem is that my sample is more than 10% of the population. And this is an issue just because we can't like draw somebody out like they're a marble and then put it back and draw again. So it's not going to be random unless we have less than 10% of the population in the sample. So just a little example of why this is a problem. I have a simulation here. I actually created, so here I have a probability of drawing a green gumball, I think, right? So the actual real probability, if we took all of the gumballs, would be 0.6. And then each one of these little dots is an experiment where I took just a sample size out. The red ones are the ones that don't include the real mean in them. So these confidence intervals are just plain wrong. And the reason they're wrong is because I took my sample size to be 200, right? But my population was 250. So 200 out of 250 is way more than 10% of the population. And when you do it this way, you're going to have a few samples that are not going to predict what the mean is correctly. So you can see down here, this is really what we're looking at. We tried this almost 1,500 times, 1,475 times. And 1,371 times, I was right, but there were a good number that were wrong. So even though we said our confidence level was 95%, we only got it right 92.9% of the time. We want to make sure that we're getting it right at least 95% of the time if our confidence level is 95. This is an example of the normal condition. Nope, I got that wrong. Independence condition. Here's an example of a normal condition. Remember, normal condition had to do with getting at least 10 successes and failures in each problem. So you can see I took the same probability, same confidence level, but my sample size now is only 15. If there's 15 people in a group and only 2 choices, there's no way that 10 people choose yes and 10 people choose no. So there's no way I have 10 successes and 10 failures. And you can see, again, I'm getting the same problem. I promised a 95% confidence level, but I only got 94.1%. And there are fewer than 10 expected successes, which is an issue. And you can see here are some of the confidence intervals that don't include the actual mean. All right, I think that is it for today. Make sure your notes are completed, and I will see you guys next class.